Greetings. My name is Ryan Niksch. I am a Senior Solutions Architect for Amazon Web Services. I focus on application platforms and application modernization. Joining me here today is Nicholas Neymar from Helvetia. Nicholas, can you give us a very brief highlight of yourself and tell us a little bit about Helvetia as a company?
Absolutely. Thanks, Ryan, and hi, everyone. My name is Nicholas, and I'm the so-called Head of Container Platform and Integration, working at Helvetia Insurance Company. Basically, I'm responsible for a group of teams engineering and operating OpenShift on AWS on the one hand side, including developer tooling like CI/CD pipelines, local development environments, and development blueprints and things like that. And on the other hand side, we are responsible for the whole integration stack. So that means all components necessary to interconnect components or services with each other. So that's the scope of my team's work. Helvetia is an international multi-line insurance company operating in 6 countries, roughly 12,000 employees, 7 million customers, and a yearly revenue of 10 billion Swiss francs. So just to give you some numbers. I think that should be enough for an intro. Back to you, Ryan.
Right. So we've had an interesting change in the industry, and that is not necessarily just in technology, but it's more so manifesting in customer expectations. Customers are almost driving the requirements of business. So if we look at a modern day customer, customers have gotten used to certain things that are being driven by online applications, and customers are starting to demand things like 24/7, 365-day access to business. And what this is resulting in is they're almost forcing businesses to increase their scalability requirements. They're forcing their businesses to increase a resilience footprint, to the point that customers are saying, if I can't access your services whenever I, as the customer, want to consume them, they'll simply go to another provider. And we're seeing this with many of the startups, and this is now bleeding into the enterprise as well. Customers also have an expectation that the applications, the web interfaces, the mobile interfaces that they're using have very rich experiences. They want features, they demand those features. And to that effect, they're expecting an ability to communicate with a company, provide feedback, and then more so, they're expecting companies to be able to respond to that. And this is in turn driving a feedback and an agility requirement. Businesses needing to be able to respond to the customer and deliver new features in very truncated timeframes. And this is resulting in enterprises needing to increase their cadence of release for software. And then, of course, customers are becoming less and less forgiving when a platform or a solution that they're consuming is not accessible. So again, that scalability, that elasticity is becoming incredibly important to the modern day enterprise because of the demands of the modern day customer. And I think to a degree, Nicholas, Helvetia went through a lot of these changes, customers demanding things from your business. Could you talk to us around what were some of the challenges that Helvetia specifically faced?
Of course I can. I mean, you mentioned it before. Today's customers are used to applications like Google, Amazon, Netflix, LinkedIn, you name it. And what those applications have in common is a superb user experience, right? So high performance, high availability, short innovation cycles. And for a very traditional company like Helvetia, with a very traditional organization, and traditional, or you can also call it legacy IT landscape, we are facing lots of challenges, technical ones and organizational ones. And if you look at the technical side, it's quite simple to explain. It's fairly impossible to achieve 24/7 availability or high performance if you hard couple your newly developed front-end solutions, so customer interaction systems, if you hard couple them on a legacy batch processing oriented mainframe with limited scalability or limited online performance. So that's the technical side. And on the organizational side, it's basically the same story. It's extremely hard to achieve short innovation cycles when your organization is modeled around centralized operating models. So with centralized units responsible for provisioning infrastructure, providing APIs, defining web application firewall rules, etc., etc. And that with only a very small degree of automation. And so those units will always serve as kind of a bottleneck in those processes. So what we're trying to do is tackle both challenges or problems. So the first solution is we provided a completely new way of architecture, completely new architecture style. On the one hand, on the other hand side, we tried to decentralize some of the organizational challenges. So to give you an idea of what type of systems I'm talking about when I'm referring to a new architecture, roughly 2 years ago, or maybe 2.5 years ago, Helvetia came up with the idea to redesign all their, we call them customer-facing processes. So that means for an insurance company, things like quote and buy, claims reports, all the portal stuff. And the vision was, or basically it still is, to build a business line spanning digital entry point to all major insurance use cases, as mentioned before, and for all user groups. And for all user groups means not only for the end customer, but also for sales agents, call center agents, brokers, etc. So that means if this system doesn't work anymore, or if it doesn't perform, then the digital entry channel into Helvetia is completely dead. And as we all know, architecture is always driven by requirements. And the requirement that most significantly impacted the architecture was user experience. And if you break it down, this means 24/7 availability, as you mentioned before. It means performance. So for example, we would like to be able to display 100 of contracts within milliseconds without waiting with a spinner for seconds or more than seconds. It means scalability, and it means resilience. So what we mean by resilience is basically we should or have to be able to fulfill customer requests in the presence of backend failures. So in our system landscape, we have lots of mainframe systems, mainframe backend systems, and they have maintenance windows, so planned or unplanned. So we have to ensure that our digital entry channel has to be stable even in the presence of those unavailabilities. And to achieve that, we came up with an event-driven reactive microservice architecture, trying to decouple our front-end user-facing applications from those traditional backends during runtime. So that was one of the major achievements that we try to make. That's basically the first part. And the second part is, so far we've only been talking about architecture, right? And the second challenge we wanted to tackle was the organizational scalability and agility issue. So this is basically tackling bottlenecks induced by central teams, responsible for extremely central tasks, as mentioned before, the installation of complete project environments, basically. And the basic idea is to enable DevOps team to do things on their own. So push responsibility into DevOps teams, but still ensuring that core governance rules will be enforced by a platform approach. So we try to build in governance rules into the platforms and ensure and guarantee them by that platform approach. Of course, we've seen lots of more challenges, but from my perspective, at least those two are the most major ones. So, Ryan, what trends and challenges are you seeing in the broader industry range?
Seeing some overlap here with many customers that I've spoken to over the last few years across various countries. We did a survey, and that joint survey data highlighted some similar trends, specifically that out of the 100 or so entities that we surveyed, something like 55% of those are looking at changing their automation. They're trying to achieve a very different orchestration mechanism, and is resulting in process change. We're definitely seeing that with the journey that Helvetia has gone through. In terms of businesses looking to deliver applications, those applications existing on cloud environments for various reasons is also a growing trend. So we're seeing 49% of those companies surveyed very, very strongly tying themselves to the cloud as part of the future of their business. And then, of course, changing the way that they develop their applications is also a very critical aspect of their new modern day business. And when I spoke to various companies, I started to see some trends as to why customers were selecting AWS as their preferred cloud of choice. And some of these are somewhat obvious. They've been around for quite some time. We've seen many customers transition to AWS because of things such as scalability. That's not to say that they couldn't scale previously. They could scale in an on-premises context, but they are limited to scale within the confines of their infrastructure investment. And they could scale to a degree, and then they got stuck in a procurement cycle that for some customers didn't complement what they were trying to achieve with an agility platform. So migrating from where they were previously, in many cases on premises, towards AWS, they're able to achieve a much greater scalability footprint. Likewise, from an availability perspective, many businesses have a resilient design, but when you're trying to reach customers in, say, a global context, or you're trying to reach a availability footprint that caters for a vast array of possibilities, natural disasters, so on and so forth, a customer trying to have multiple data centers around the globe that is highly resilient, that is an incredibly expensive investment. So transitioning to AWS allows you to achieve that same availability, but with less responsibility on your own business. You don't have to build your own data centers. You don't have to stand up teams to maintain those. Likewise, you mentioned this, the elasticity desire, the ability to add resources, tear them down, spin up entirely new architecture building blocks through very simple API calls through either a web interface or infrastructure as code or a CLI, allows customers to build really innovative solutions without having to invest tremendous effort and an engineering effort. But what stood out for me was many customers are selecting AWS not just as an infrastructure as a service platform, but also because of the very rich service portfolio, those almost 200 AWS services that cater for databases, caching layers, messaging and notifications, AI, ML, and each of these services are built from the ground up to be scalable, available, highly resilient, secure. And this means that customers don't need to invest effort into solving these problems themselves. They can simply deploy these in a very elastic fashion, manage them, and then use them to complement their workloads running in other platforms. Now, Nicholas, Helvetia selected two things that stand out for me. One of these was Red Hat OpenShift as a orchestration layer, as a platform, and you have deployed OpenShift on AWS. I would love to hear what the aggregate benefit for Helvetia was. What is Helvetia really getting as a benefit from using OpenShift on AWS?
I think I would like to split my answer maybe in three parts, if that's okay. So, and all of them are bound to customer requirements in the end. For me, in general, it doesn't make sense to build cool architectures just for the sake of cool technology. So it should always be bound to a customer benefit, right? So three parts. The first one is general new requirements. The second one is agility, and the third one is innovation. So starting with new requirements, I mentioned it before. Today's users are used to amazing user experience, simple UIs, performance, resilience. We discussed that before. And we can only achieve those requirements and fulfill them by new architecture styles, as discussed before. And for those styles, we need a completely new type of infrastructure. So we need a container runtime, being able to build microservices. We need things like Apache Kafka for event-driven integration. But we also need a infrastructure layer as the fundament for that. And we use AWS using that with an extremely high degree of automation. And we are, of course, using as much higher level services as possible. So AWS and OpenShift are absolutely crucial to that idea. So we are not able to build those types of architectures without OpenShift and AWS as a fundament. So that's new requirements. The second one is agility and time to market. So from my perspective, a DevOps operating model pushing responsibility into DevOps, into dev teams, really helps in increasing agility and reducing time to market. And a platform with an amazingly high degree of automation and self-service capability is absolutely key to that. Otherwise, it won't work. And again, the fundament for this automation and self-service capability is AWS and OpenShift and the interplay of both of them. And from my perspective, agility is about, short release cycles, inspect and adapt, trying out things, evaluate them, going very, very early on the market for a small user group maybe, and simply try out things. And AWS offers a huge toolbox, you mentioned it, a diverse range of out-of-the-box services ranging from low-level things like infrastructure to higher-level things like speech recognition or machine learning toolbox. And what AWS helps us amazingly with is we can simply use those services out of the box with a minimal ramp-up time, minimal initial cost, and evaluate new business ideas. So that's the heart of agility from my perspective. And the third one is innovation. It goes basically on the same line. So AWS is iteratively investing in new services. You mentioned you currently have like 200 of them. Maybe next year it's 250 or 300. So you're always investing in those services. So we are, as a company, we are participating in AWS's innovation cycle on the one hand side, and we potentially, from my perspective, also participate from other industry domains, because I guess that if they have hard requirements, they will push their ideas and their innovation into the AWS platform. And the last point I would like to make is introducing containers as a new unit of operation increases standardization on the operations side. And as a consequence, it reduces operating effort, right? And the same applies for shifting workloads from self-managed environments like we previously had with our on-premise data center to managed services in the cloud. So on the long run, we are reducing operating effort. And this move, from my opinion, should enable us to concentrate our engineering power on the insurance key domains instead of wasting, quote unquote, our energy in operating infrastructure, for example. And so we should be able, on the long run, to shift IT resources from operations to engineering new business functionality. So that's the big goal. I can just go to the next slide. The question now is, what have we achieved so far? So we started roughly a bit more than 2 years ago with our cloud journey. And since then, we introduced a fully automated OpenShift cluster based on AWS services. I mentioned it before, infrastructure as a base layer, but also higher level services within a bit more than a year. Of course, we're still working on it. We're still improving, but it took us roughly a year to bring that platform in production. We introduced a completely new cloud native architecture style, as mentioned before, to guarantee this new type of user experience with 24/7 processing, high performance, high resilience. We discussed that. We massively reduced time to market for new applications. So in our old on-premise world, with limited automation capabilities, the overall provisioning process for a new project or new application where you need a server and an application server on top of it, an operating system layer, etc., provisioning this infrastructure took us several weeks elapsed time at least. And now we are down to minutes based on fully automated infrastructure and provisioning process. And of course, at the beginning, when we started the journey, we had tons and tons of applications in our on-premise infrastructure running on this legacy infrastructure. And we are still in the process of migrating those applications, especially the Java workloads, to OpenShift currently. We already migrated the majority of it. And the big goal is to deprovision the old infrastructure as soon as possible. So we anticipate a significant reduction in hardware and operational costs in the long run. But this has to be proven. But at least we anticipate it.
Now, you mentioned earlier on where you spoke of enabling developers, where you were shifting the responsibility to your developers. How has Helvetia solve the problem of, if an application or a development team wants to consume an AWS service, something like a database, for example, how are they getting access to those services? Is there a cloud center of excellence that is, say, provisioning that for the team, or is the team very much self-enabled internally in Helvetia?
Basically, it's all based on self-services. So we don't have a central team still provisioning things. The vision is that a DevOps team is completely enabled to do everything on their own. So in general, we are trying to automate as much as possible using infrastructure as code approaches, and on top of that, using tools like Ansible or Terraform for the automation process. And on top of that, we offer self-services, either using more high-level tools like, for example, Jira, where you have simple forms that you can fill, and when you press the accept button, then the pipeline will start running and provision things for you. Or for more developer-centric things, we use GitOps flows. And don't be afraid, I won't go into details on this slide here. What we came up with is basically a 3-layer approach. On the first layer, a developer or a team is able to provision very basic infrastructure components, like, for example, Kubernetes namespace with a predefined staging structure, or a Git repository, secrets management, a basic CI/CD pipeline based on a simple Jira form. And so far, on that first layer, we are completely still technology agnostic. So you can use every type of programming language or runtime that you like, R, Python, Java, whatever. On the second layer, on the second step, we offer templates for typical use cases, application use cases or scenarios. So, for example, a typical web application that is usually developed at Helvetia, so that's one of our standards, with a Java Quarkus backend and an Angular UI component. And what you can do as a developer here is you simply clone a Git repository. And from that point, you start with a hello world web application in this, let's say, basic architecture style and technology stack. So this is to massively speed up your initial ramp-up time. And then there's the third layer. And now I'm coming back to your question. This is where we offer diverse, higher level services, I would say, like relational databases, like NoSQL databases, like a search index, S3 object storage, provisioning or connecting to a Kafka topic, and all that in the AWS service space. And the basic idea here is to automatically provision those services and connect your application or the microservice or whatever you're currently working on to those services, all based on a self-service approach. And this, Ryan, brings me back to a very interesting question. I mentioned earlier that we're trying to move as much workload as possible away from our on-premise data center and from self-managed things to managed services in the cloud. So are there any plans on AWS or OpenShift side that you think might help us on that journey, shifting more towards managed services?
Yes, in fact, earlier this year at a Red Hat Summit, Red Hat and AWS jointly announced a new joint managed offering of OpenShift. Currently, many customers are deploying OCP, the OpenShift container platform, which is a self-managed implementation of OpenShift. So the customer would have to deploy OpenShift into their AWS account. They would have to monitor and maintain it. They would have to deal with the subscription costs of OpenShift through Red Hat, and then the infrastructure of AWS through their AWS accounting. And we've gotten a lot of feedback from customers that customers were looking for something that is managed, something where another entity could look after the OpenShift cluster on their behalf, and they can focus on consuming that platform, really building the applications within it without having to worry about, what is the health and status of my master or my etcd layers. So what we have created is a new managed offering, and this is going to be very much console integrated. The intent here is to further reduce operational complexity and really take the benefits of OpenShift as a developer tool and provide that to customers without having too much of the operational or administrative side. So directly console integrated. Previously, if you wanted a managed offering, you'd have to go to Red Hat and procure it from them, then come back to AWS, then go back to Red Hat and have them provision it into the account. With the new managed offering, customers will be able to go to the container services offerings from AWS, where you would see our native ECS, EKS. You will now see a Red Hat OpenShift offering. Click on a button. That console experience will take a customer through signing up for the procurement process, purchasing the product, as well as kick off an automated deployment and provisioning process. So it'll deploy this into the customer's account. Once provisioned, Red Hat continue to support that platform. So they'll monitor it, they'll back it up, they'll patch it. If something fails, they'll automatically detect that and address it, which means that the customer isn't investing effort over here. Customer also gets a unified billing platform. So from their AWS bill, they will get the billing from whatever is in that AWS account. So the compute, the networking, the data charges, the storage charges, and they will also get a consolidated bill for the OpenShift subscriptions. What is very exciting for me, this is the first OpenShift implementation on AWS that has a consumption-based billing model to complement what you have with other resources on AWS. So your OpenShift subscription is now an hourly billing entity, meaning if you deploy a cluster of OpenShift in this managed offering and you then tear it down an hour later, you literally only pay for that hour that you are using it. If you have to scale up over a busy period, you obviously pay for that scale up. But if you then scale down because that use case requirement has reduced, you only pay for what you used. And that is a dramatic cost saver to enterprises. And then, of course, very important to many enterprises is that there is a support offering. And in this case, there is joint support. So AWS and Red Hat have created a innovative flow between the two. Both sides will manifest tier 1 and tier 2 support models. And if needed, both sides have the ability to escalate to tier 3. So if you as a customer reaching out to Red Hat for support, Red Hat will assist you with tier 1 and tier 2 support on the AWS side. And if need be, they'll escalate on your behalf to AWS. And the reverse is also true for customers opening support cases to AWS. So really a reduction of effort from the customer. The customer doesn't have to open up 2 support cases. This is something that is going to be generally available later this year. We're anticipating in this fourth quarter, so do keep an eye out for that. Nicholas, I think this is something that very likely would complement Helvetia. Thank you very much for joining me here. It's been fascinating hearing about the challenges and the solutions that Helvetia have put into play. Thank you, everybody, for joining us in this session.
Thanks, everyone. And thanks, Ryan.